Day one, exploration one, and this is the experiment we were using with the bug picture. So, in exploration one, lens one, we had lens one, and the object could only be seen clearly if you move the drawing of the bug close to the lens. Otherwise, you couldn't see the image clearly. If you flip the lens, it couldn't make a difference whether the image would be seen different or not. Lens 2 is sort of like the same thing. You have to bring the drawing of the bug closer to the lens in order to see the image clearly. And flipping it also didn't make a difference. You could also just see the image clearly on either side. On lens 3 is different. You had to move the drawing of the bug further back in order to see the image. Also, flipping it didn't make a difference at any time.
For day Tuesday of the lens week, we took pictures of what we did. We just basically measured. We just basically saw the light rays reflected from the light source. We used lenses 1, 2, and 3, and there was different kinds of light sources. The light sources would either be bright and visible, or some light sources wouldn't be that visible, but we could still see them. Like for this one. The light from the handle stretched out the paper, so the light rays will be either small or big, depending on the lens one. The lenses. The lens 1, the light rays were short. For lens 2, the light rays were still short. When we moved on to lenses 3, the light rays got bigger.
This is experiment 4. It's about a Wednesday, and we were recording data for the focal point and measuring the focal point through the screen.
That's shaking.
This focal point was about 9.8 from the light source, 9.8 centimeters. And this is lens 2. The focal point was measured at 14.2 centimeters from the light source. Lens 3, the focal length is 5.8, and the length is shorter than lens 2. When the candle is close to the lens from far away, it was blurry. When it was in the middle, it's clear. The measurement of the lens to the candle is 17.5 centimeters, but the measurement of the paper to the lens is 21. When we move the paper forward, the image gets blurry and larger, but moving back, it takes shape and it's much clearer.
Day of the lens week, we tested 1, 2, 3, and 4, and we had to use lenses 1 and lenses 2 for each experiment. The numbers basically increased more, but for distance of the screen from lens 1, they decreased. And for the distance of the candle from lens 2, it increased. And the distance of the image from lens 2, it increased also.
It is day 5, Friday, and what we did is we saw through a frosted glass how close or how far you could see a clear image through the lens. With lens 1, we used 20 centimeters away from the candle to the lens. It was from the lens to the image, it was 23 centimeters. It was large, upside down, and you saw more brightness. The second, 30 centimeters, and the image to the lens is 17, larger, upside down, but less.
Basically, it just decreased.
Exactly. The more it goes up, the more it decreases. And for the second lens, we did 10. There was no image whatsoever, so we couldn't find anything else. But in 20 centimeters, we found it on the window. It was large, upside down, but it was less. And then 30, and then on 30, it was still on the window, but it was still large, upside down, but it was more. And with the last one, 60, it was 40.2 centimeters. It was smaller, but it was still upside down and still had more. But when we used lens 3, it was close up. When the lens was close up to my eye, I couldn't see anything. But from the distance, I could see everything much clearer.
Summary with Danny and Tyler.
And Suzette.
And Suzette.
Yeah. Okay. For concave lenses, there's a big difference. Like this type of image, you can see only inward, and you can only see from a short distance. Yeah.
Okay, and a convex mirror is the opposite, which is outward. Like if you go to a grocery store and you see like the little mirror and it's popping out at you, it's like that. It's much blurrier than a concave, so you can't really see it.
Yeah, you can see images further out. And different perceptions of light could be seen in both lenses. Like concave, you can only see like a type of light so far. Yeah.
Okay, for like the different images, for like each one, it's like when you hold it at a distance, they're much different. They appear. Like if I hold a convex, like if I hold it outward, I can see everything, but if I hold it close up, I can't see anything, which is the opposite of the lens, concave. So at different angles, at different distances, it becomes more clear or blurry, but it depends on everybody's eye. Most likely it's the same with everybody.
Yeah, and if you flip a lens, you couldn't really tell the difference between images. Like, it's the same.
But you can tell by the side, because one will be out more than the other, like my glasses, which are convex.
Yeah. And showing the materials, we have this is lens 2.
It's still
Yeah.
concave. That's concave. This is convex, and the other one is just a regular magnifying glass.
Yeah. We have
Cardboard. It's a cardboard.
and you have
We use this with the light.
To get the light rays.
Yeah, with a candle. This candle, small. I had different candles because they kept moving. Like this ruler thing. It's like a ruler. Distances. And the beetle, which was our first one on experiment.
we have the holders of concave, convex mirrors, and the paper, the screen.
Here's another screen.
That's the frosted glass.
This is the frosted glass. The frosted glass. That's pretty much it. And then now to my overall experience.
Okay.
Then would you like to start or cut this in?
Sure. The overall experience of this project was fun. I got to see different types of experiments, like going on with candlelight. I didn't know that you could see an image of a candle upside down, and I didn't know that you could see different light. I didn't know you could see different light farther out, closer in. You can also see virtual images. That was really cool. I didn't know that.
Tyler.
Look, it's my turn. Okay. Overall experience, basically. Okay, basically through the overall experience is the differences between lenses, which one does what, at what angle, what distance, can you see stuff clearly, and the different light from candles or sun, no matter what, is still a light. Also, the different images, like it could be a big image, it can make it smaller, it can make it larger, whatever the case may be, and yeah.
So basically, we got to use different types of lenses, lens 1, lens 2, and lens 3. And with those different lenses, we saw different images. When we would use them, we would see different light observed from the candle, like the small flame and the big flame. And sometimes we gotta measure them out, and sometimes the measurements would be close or far away.
The main idea was to find the focal point and to measure out the distance from the focal point to the lens with the candlelight.
To the point where you could actually see the image at the proper angle of light.